Hello, so today we are going to do problems from biweekly contest 102. So the first problem is find the width of columns of a grid. So what this problem says basically is that we have an n by n integer matrix grid, and we call the width of a column the maximum length of the integers of that column, right? So for example, the length of minus 10 is actually 3 because we count this minus. And what we are asked to do is given a grid, so a matrix where we have multiple rows, each row with multiple values, we want to take each column and get the max length of all the numbers in that column, and then at the end we want to return result array or answer array where each answer array at position I will contain the maximum length of the values in that column I. Okay, so for example here it's easy because it's just one column. We can just take the max of all of these, and so the max length is 3 with this one, last one. Okay, so we return 3 for just one column. For the second example here we have 3 columns, and so for the first column minus 15, 15, 5, the maximum length is 3 here, and so we return 3. For this one 1, 7, 6, the maximum length is 1, and then for the last one 3, 12, minus 2, the maximum length is 2, with minus 2 and 12, and so we return 2. So that's the idea. Now how do we handle it? Okay, so how do we, well, we can handle this just like doing a brute force solution. So how do we handle that? Well, we can just go through the columns, and so to go through the columns we need to of course know the number of columns. So let's just calculate that. So it would be just the number of cells in the first row, that would be the number of columns, and then for each column we want to check the value at that column for each row, and so we need to go through the rows, right? So this would be a range of rows, and then we also need rows is just the number, the length of the grid, and then after that we need to have a result, right, that we are going to return at the end. This would be just the max length for each column, and so we need for each column we need to keep track of the max length. So let's start out with 0, and then we can just look at each element. So the elements are ij, and then we need to convert it to a string to get the length, and then from there we can take the max of that with the max length so far. Okay, and so we need to close this, and this would be the max length, and then we can just add this to our result here before returning, and that should be it. So let's run it, let's submit, and that passes. Now in terms of time complexity, that's O of C by R, so C being the number of columns and R being the number of rows. And then in terms of space, it's O of C because it's just the number of columns. Now we can change this slightly just to make it easier, to make it shorter. So with grids, you can actually get the columns by just doing a transpose like this. So if you have a matrix A, to get the columns in the row as rows and the rows as columns, you can just transpose it, and to transpose it you could just do a zip like this, and so that's what we can use here. So let's just to do that, well, we can just go through the column. So the column would be just like this, and then for each we no longer need this. For each column we want to just take the max of the length, right? So the length of each, let's call it x, and then x is going to be for just in the column, right? Because we want the maximum length of the column, and so we can just add that to res. Okay, and that should give us the same thing, except here this needs to be grid. Okay, let's submit, and that looks good. Now now this is actually no longer needed because now we can just, this is less readable in my opinion, but if you want to do it, you could just do it as one-liner like this, and that should work, and we could just return this, and that should pass. Let's run it, submit, and that passes as well. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.